Welcome to your third video in Unit 4, and today we're going to talk about specific types of triangles and being able to calculate the angle for any triangle, not just the ones that you may learn on the unit circle, but any different angle. And we're also going to specifically talk about the unit circle. So what I would first like to remind you of is when you have an angle, remember theta is the interior angle there. It's off the initial side and this is the terminal side. And when you are finding a point, remember you're going to rise a y. This would be your x value. Your r would be your radius. And if you can always make a right triangle. And let's calculate what r would be. R would be this, r squared would equal x squared plus y squared. So r would equal the square root of x squared plus y squared. And you're going to have to calculate that at some point because you now can get values for the 6 trig functions using r, y, and x. Let's go back and remember SOHCAHTOA. So if you're dealing with the sine, that was the opposite over the hypotenuse. Well, here, if I've got my theta, the opposite would be the y over the hypotenuse, which is r. So you can also find the sine as taking the y value over the radius. Also, the cosine value would then be the adjacent side, which is your x, over the radius. The tangent would be the opposite over the adjacent. So if I put y over x, well, y over x would be the same thing as sine over cosine. If I take sine, y over r, and divide it by cosine, I would multiply by the reciprocal, right? The r's would cancel and I would have y over x. Now let's get the reciprocal functions for cosecant would be r over y. Secant would be r over x. And cotangent would be x over r. Now we don't ever have to worry about r being 0 because r is the radius. But we do need to make a point of making sure that when we have x and y in the denominators, that they are not 0. So you may just want to tag that on there because we can't divide by 0. So this is understanding that those are not 0. Cotangent would be x over y, not r. Let me fix that real quick. X over y. Now another thing I want you to remember is that since r is the radius, it is a distance and it can never ever be negative. It's always positive. That will be important, all right, when you're trying to figure these out. Let's talk about some of these quadrants too. And this should be review. When you look at a quadrant system, we are going to refer to, obviously, quadrant 1 is where everything is positive. Okay, and then quadrant 2, 3, and 4. Now, if you remember from up here, the cosine, we did that was our x value. Cosine is always x. So let's look over here in the quadrants. If cosine is x, this value in here, the x value in quadrants 1 and 4 are both positive, aren't they? But the negative cosine would be in quadrant 2 and 3. Now, sine is your y value. Sine is going to be positive in quadrants 1 and 2 and negative in 3 and 4. So it's important to remember those. And I think you already know those, but you will need to refresh your memory and remember those. Now let's talk about the tangent. Tangent, remember, is sine over cosine, and we can prove that with these values up here as well. But you need to remember tangent is always sine over cosine, therefore cotangent would be cosine over sine. But let's talk about the signs, S-I-G-N, of tangent within the quadrants. So if tangent is sine over cosine at positive divided by positive, it is positive. Here, if I have a negative divided by negative, sine divided by cosine, I'm going to also have a positive. In quadrants 2 and 4, however, I'm going to have a positive divided by a negative or a negative divided by a positive, which will make my tangents negative. And that will be important to remember when that happens. So you'll need to get those in your mind as to what quadrant and what the signs are. Let's do an example. If you have a problem that says, example 1, if you have -2, -1, and that point is on the terminal side of an angle, find all the other 6 trig functions. So -2, -1 would be right about here. That point, that lies on the terminal side. All right, and I can draw my right triangle. And what you're trying to find is the sine, cosine, tangent, cosecant, all of those of this theta right there, the interior angle right there. Well, you already know that this is a -2 value, correct? And you know that this is a -1 value. So we can calculate what the radius is. The radius squared would be -1 squared plus -2 squared. So that would give us 1 plus 4. So we have r squared is 5. So r must be the square root of 5. So I'm going to come back up here. That goes right there. Square root of 5 is r. Now you can get all 6 functions. Let's write those in. Sine would be the y over the r. So this would be -1 over square root of 5. Yes, I know I need to rationalize it. I'll do that in a minute. Cosine would be -2 over the square root of 5. Tangent would be the -1 over -2, which would just be 1/2. Now let's do the reciprocal before we go back to rationalize. It will make our life easier. Reciprocal of 1/2 is 2. Okay, flip this. That would give you the square root of 5 over 2, but it's negative, right? So we're going to stick a negative out front. It doesn't matter whether the negative is in the numerator or the denominator. We usually put it out front or in the numerator. This would just give you negative square root of 5. You don't need to put over 1. Now go back to rationalize. You rationalize this by square root of 5 over square root of 5. So your answer is negative square root of 5 over 5. The cosine value, can you see what that would be? That would be -2 on the square root of 5 over 5. And those would be the 6 trig functions. You had to calculate what r was first. Also, we found, remember, that it was in the third quadrant because of the point, and r is always positive. So when we're substituting it in, we had a negative x and a y, cosine and sine, but we were able to plug those in and keep the r positive. The next thing I'd like to talk about are reference angles. Reference angles are useful in quite a bit of our work, and that is the acute angle formed by the terminal side of the angle and the horizontal axis. It's the shortest distance to get to the horizontal axis. So for example, if you have, this would be the initial side of an angle, and I'm over here maybe in quadrant 2. So this is my theta that I am measuring. Well, the reference angle for that theta would be right here in this distance. It would be the shortest distance right here, formed by the terminal side and the horizontal axis. So that we call, you may see it as theta prime. That would be your reference angle. So the fastest way to do that would be to take 180, and you can, or to take your angle from 180, and that would leave you with the reference angle. You can also have, let's say this is your initial side, and your angles down here may be in quadrant 3. So this is your theta. All right, more than 180, not quite 270. Your reference angle here would be what this is right here, this angle. It would be what it would take to get to the horizontal axis. That would be your theta. That would be your reference angle. So sometimes I'm just going to ask you, what is the reference angle for, and you have to subtract from 180 or subtract. Here you could subtract the angle. If you're given that angle, you would subtract 180 from it and you would know what was left. All right, let's move on. Example 2. This says if the sine of theta is 5/7 and cotangent theta is less than 0, find the other 5 functions, because you already know sine. So it wants you to find the other 5. Well, you first need to figure out where this is, get a triangle, figure out R. You've got some work to do first. Well, let's first figure out where the triangle lies. This says sine of theta is 5/7. So that means I'm either in quadrant 1 or in quadrant 2, because sine is positive. So I'm in 1 or 2. This tells me that cotangent is negative. Remember from our quadrant work earlier that tangent and cotangent, because they're reciprocals of one another, are negative in 2 or 4. So if both of these are qualifiers here, then we know we must be in quadrant 2. That helps. So if we're in quadrant 2 and I am going to have my sine value is 5/7, that means that that is my y over my r. So my y is 5. Means I'm going to come all the way up here. And this is 5. I'm in quadrant 2. My r is 7. I want to figure out what x is, and I know it's negative because I'm in quadrant 2. This is my theta. So we have 7 squared equals 5 squared plus x squared. You have 49 minus your 25 is going to give you x squared, which is 24, and you can't leave it that way. That would be 4 times 6. The square root of 4 is 2. So 2 on the square root of 6 is your x. And you know that it's important you're in quadrant 2, so it's negative 2 on the square root of 6. Now go through and plug in your values. You already know that sine is 5/7. So cosecant would be 7/5. Cosine would be x over r, so that would be negative 2 on the square root of 6 over 7. Tangent would be y over x, so I have 5 over negative 2 on the square root of 6. You need to rationalize this one and reciprocate these, and we will check those when you come in the next video. Thank you.